All right, this is Unit 1, Day 7a, and we're going to be doing some modeling with functions. So when we say modeling, it just means we're trying to look at a problem. We're trying to find some sort of function that helps us predict or kind of summarizes it quickly. So some of this we've done already. So I can find a function of best fit line from data. So just a quick review how to make a scatter plot. If you push stat, edit, put your data in. Once you get your data in into L1 and L2, and it could be any list really. We just stick with L1 and 2 is kind of the simplest way of doing it. And we're going to let L1 in this problem be the year since 1990. So that means this would be 0, 5, 10, and so on, 12, 13, 14, 15, 16, 17. And then this would be list 2 is the housing CPI, which is just consumer price index. We want to, first off, try to see what kind of a pattern we see here. We did linear, and in Unit P we did some linear stuff. All of them were linear. That's not always true. It's not always going to be perfectly linear for us. So we're going to have to look at it. And that's what down here, we want to first make our plot. Maybe we'll do that first. So let's enter that data. So pause your video and put this in your L1 and L2. Again, I've got L1, L2. Ignore L3 and L4. That's a different problem. I just don't want to delete it yet. But I put the data in L1 and L2. And it's, here we say second stat plot. Make sure that this is on. I'm going to make sure this one is actually off. Yours probably won't be. So you don't have to worry about doing that. But go to plot 1. Make sure it is on. Make sure that the scatter plot is the one selected. We haven't changed those yet. Make sure list 1 or L1 is your X list and Y list. Then push zoom and number 9, zoom stat. And you look at this and it sure seems pretty linear here. But if we look real close, it almost seems like it might be having a little curve to it too. Okay, so we want to look through. I put it on the pictures here. We got linear, we got quadratic, we got cubic, we got quartic, natural log, all the way through. You can kind of read all those if you really squint, but all the way through, all the shapes we're looking for here. So on this one, I'd say could be linear, but I don't think it is because it is turning a little bit. Could be quadratic, and it could be cubic and quartic, but I'm pretty sure I only see one curve there. And then exponential is another possibility too. And the problem is you'd have to take like college level statistics to really tell which one is the best one. But we're going to kind of stick with we'll stick with quadratic on this one because when I do linear, that's a pretty good fit to it. In fact, let me do the linear. So we'll do linear, do L1, L2, store this. When I go graph this guy, if you notice this line, it's above, 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 below, below. It shouldn't be like that. It should be scattered all about. It should be above, below. It should be just kind of a random pattern. And this one, that tells me that there's a curve coming down through a straight line. Okay, so there's a straight line, a curve going through it. So I don't really want to do that. I'm going to go back. And that might have been a little bit, it's a little misleading because my R values are extremely strong there. It's just, if I look at it in more detail, it's not linear. It's actually got a curve to it. So I'm going to go through, I'm going to do a quadratic. So quadratic regression, and the steps are over here. If I'm going too fast, you can look over here. I'm going to do quadratic regression with these two. And I'm going to store this one. Actually, I'm going to go Y2 instead. So this is in Y2, and that way I have both equations I can look at. And again, look at the R. Now, on quadratics, there's not an R value. There's an R squared, though. And R squared is still the closer to 1, the better. And so R squared is 0.998, which is extraordinary. That's really good. Of course, the linear was very good, too. Now let's go look at the graph of that guy. There's a linear, which has above, 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 below, below. This guy here has a little bit of everything. It's kind of bouncing back and forth, going through a lot of those points. So it does fit it a little bit better than the linear did. Okay, now set this aside. I want to save the data. Don't clear that data for later. Let's turn this over. Now, this is an explanation of what R and R squared are. We won't go into great detail, but just there is a difference. One is called the correlation coefficient. That's little r. The coefficient of determination is big R squared. I think that's just so you can tell a difference between the two. But R squared is literally R squared. So if you know your R value, you can find R squared and vice versa. Now, if you know the R squared and you want to go back and find the R, you have to be careful because anytime you square root, you have a positive and a negative root. And the sign on the R is important, whether it's positive or negative. R squared will always be positive. So you have to kind of be careful with that. So what the calculator is doing is it's using the errors, which are the vertical distances between the best fit line and the actual data. Okay, so you got those points going through here like this, and the line goes through it. It's a little bit off, a little bit off, a little bit more off. That one's almost perfect, a little bit off, a little bit off. These are all the vertical lines. It's making a statistic out of that, and it's trying to measure how well it actually fits. So in general, the closer R is to 1 or -1, the stronger the correlation and the better the fit. If you've got a kind of a hodgepodge, which down here are some examples. If you've got these are perfectly lined up. All these dots are perfectly lined up. That would have an R value of 1. Okay, so correlation coefficient is your R value. This is pretty good. They're all following the same path, the same pattern. As X increases, Y is increasing. So it's pretty good, and it is positive. So that's why this is a positive 0.8. So 0.8 is okay. It's not super strong, but it's pretty good pattern. Notice 0.4 is kind of weak. I can barely see that, but that's kind of following a path here like this, but it's still not great. Here, I just got, looks like a literal shotgun blast in the wall. You shoot drywall with a shotgun, you're going to have no correlation. It's not positive, it's not negative, it's nothing. Okay, now this one, just as scattered as this one, but if you notice, it's kind of following a trend of going down, so that's why it's negative. It's just as strong of a correlation, but the direction is as X increases, Y is decreasing. And this last guy over here is getting stronger, but it's negative. So negative doesn't mean bad, it just tells you basically what direction, what's the slope of the trend that's going on here. So a lot of students, they see negative positive as a good versus bad thing, but it's not on this one. So let's see if you can identify, and this is just by comparing, and this isn't like you're supposed to memorize what a 0.95 R value looks like or anything like that. It's just if I compare these 6, I can narrow down and figure out which one of these goes with which one of those. Let me say I did have a typo. This should be 0.75, and a 1 snuck in there. So look at these guys. First off, let's go negative positive. So these guys are negative, and all the other 4 are, well, 3 are positive, 1's nothing. And then that might be the easiest one to identify right off the bat. Which one of these has no correlation whatsoever? It's not positive, it's not negative, it's not even lining up. I can't see what direction it's going. Okay, and that would be this right here. So B. So that has a 0. I'm just going to write the numbers down here too. So this goes with B. Now think negative. Out of all these, which ones are negative? Well, here's a negative, here's a negative. The rest of them, this is positive, positive, and just slightly positive. It's going up. So these are both negative, and this one's stronger. So what would be considered a stronger negative would be negative 0.88. So that's F. And then the other one would be a negative 0.71. So that'd be A. Okay. Now, look at the positive ones, because we got 1, 2, 3 left. Strongest, next strongest, and then third. It's not weak, it's just the third strongest. So out of these guys, which one is the strongest, most tightly packed together? And I'd say this guy, letter C is. So it's C, that's 0.95. And now 0.75 compared to 0.82, which one of these is stronger? And you might be thinking, well, this is a steeper one. That's a higher value. That's not necessarily true. It's how tightly packed it is. This is tightly packed. This is a little bit more spread out as it's going through. So this is going to have a stronger 0.82. and then this would be the 0.75. So that's your D. Okay. So that's just comparing. You don't have to really recognize. You can never just look at it and say, oh, that's a 0.94. That's not going to be possible. But if I asked you to compare a 0.95 to a 0.7, that's easy. You can tell which one it is, and then negative versus positive also. Okay, so back to the CPI problem from the front. We got our data. Okay, so I'm going to open up my list. And they want us to add a few more points here. So again, years since 1990. So that means this would be an 18, 19, 20, 21. 18, 19, 20, and 21. I've got some, let me cover this up. We'll ignore the actual and do the predicted. So the predicted on this would have been these guys. Okay, maybe I should go back here. So we wanted to go with quadratic. So I'm going to turn this guy off. Let's see, what is our predicted? So I can go to, I'm going to graph that guy. Whoops, zoom, 6. Okay, just realize why it's giving me an error. Don't put those numbers in yet. Okay, so delete those 3 numbers I just put in, 18, 19, 20, 21. So let's go to, zoom. And there's my parabola, because we're going to stick with the parabola line. And if I want to do some predictions, I could do it push trace. And if I want to know what should 18 be, I'm going to type in 18. Whoops. Trace. Okay, make sure right now it's following the dots. I want it to follow the red lines. I'm going to push down so that way it changes to Y2. And I'm going to put in 18. And it says 214.86, which is my predicted. Type in 19. Again, this is after going to trace. Oh boy, I got to zoom out a little bit apparently. Or my window, let's change my max to 22. And I'm going to trace, I'm going to type these numbers in, and I'll get these numbers right here. Now, were our predictions correct? These came from that quadratic function. Well, let's slide this over and look. They weren't correct. Okay, so things change. It looks like there was a pattern. We're talking about houses here. If anybody knows what happened with houses around 2008, we had a great recession, stock market crash, the housing, nobody could pay basically everyone got a loan that wanted a loan and nobody could pay them back, and a whole bunch of bad stuff happened. So the CPI leveled off and started to drop. So you went back down this direction. So were our predictions correct? No, they weren't correct. Why should we be careful predicting the future with regression? We shouldn't try to go too far beyond our domain. Our domain with our data that we collected was between 1990 and 2007. So we should only make predictions in between 1990 and 2007, and maybe just a year or two out from that we could say, but the further out you get, the less uncertain we are that it's accurate. So this one, again, that's called extrapolating. Extrapolating. We don't want to extrapolate with data, okay? There was a problem I read once about oil prices in the 1970s, and had we continued with the current trend, we'd be paying almost $30 a gallon right now, but it didn't happen. So, at the time, oil was going like this, and then it leveled off, and then hurricane, in the late 2010s, Katrina hit. And then prices right now are back down to here. They got up to $4. Now they're down around $2. There's no pattern to that, so we can't always predict using regression. But it is helpful when used within the domain of your data, the X values that you actually collected.